$120,000. Now, as an ordered pair, because if we go back to our table, we notice that we called 2009 year 0, we would have the ordered pair 0, 120. Now this, of course, anytime your initial value, or anytime you're dealing with an initial value when the input is 0, this is exactly the vertical intercept. Now that doesn't really come as a surprise because we've been calling it that already, but that's what we often call our vertical intercept, where our function crosses our horizontal axis. Now certainly it kind of looked like this, but if you mathematically kept going, this function would go on in this direction. Similarly, you could kind of go back in time, and for every year you go back, you would remove $6.7 thousand. So this mathematically this function goes on forever in either direction. Similarly, the rate of change, or the slope, we could interpret as, on average, the home increases by $6.7 thousand per year. And we probably want to say that this is between 2009 and 2012, because it doesn't necessarily always increase by that. That was just the average between 2 years. Let's look at another one where we can, I don't know what happened here, we don't necessarily have the initial value. So this is the other type of situation which we want to model where the initial value is not known. So let's see what's happening here. Long distance truck driver is asked by his employer to keep track of his fuel consumption and distance traveled. So fuel consumption and distance traveled is what we're looking at. Those are our two variables. He finds that after having driven 186 miles, he had 15 gallons of gas remaining. Upon arriving at his destination, 320 miles away, he needed to refill as he only had 1 gallon remaining. Assuming a constant rate of change, that tells us that we're going to be doing a linear function. Create a function that models the amount of gas remaining, we'll call that G, as a function of the distance traveled, D. Okay, so that means we're modeling G as a function of D. So if we think about this, what's our input, what's our output? Well, output is always a function of input, and so if we think about this graphically, on our output axis we're looking at gallons, and on our input axis we're looking at the distance traveled. So what do we expect? Well, we already see that as he's 186 miles out, he only has 15 gallons of gas left, but then as he gets to his destination 320 miles away, he only has 1 gallon left. So we can see that this is going to be a decreasing function, that our output, our gallons, are going to be decreasing as we drive more and more, and we would expect that. So let's think about this in terms of a table. What do we have? So we know that we're going to be modeling our input, which is distance, our output, which is gallons, and we don't have the initial how many gallons we had at the initial distance. We're going to need that. We don't know right now what this value should be, but we do know that after traveling 186 miles, so somewhere out here later on in the table we'd have 186, there were 5 gallons remaining, and after 320 there was 1 gallon remaining. So now we can kind of use this information. First of all, we need to know, well, how much gas is being consumed. What are our units going to be? Since our output units are gallons and our input units, well, it's distance traveled. How are we going to measure distance traveled? Well, it's in miles. So our unit of measurement is going to be gallons per mile. How many gallons of gas we use for each mile driven. Now, usually you think about it in terms of miles per gallon, how many miles you get per gallon in your car, but in this case we're wondering how much he consumes for every mile that he drives. So let's see what happens. Well, for the data that we do have, we see that there's a decrease of 4 gallons. So I could do 5 minus 1 or 1 minus 5, but I know it needs to be negative since the gallons drop. On the other hand, my miles increase. I could do 186 minus 320 or 320